In this section, we're going to talk about the properties of logs. The first property that we have is the product property, and that says if we have the log base b of x times y, we can break that up into two logs that are being added together. So we could break it up as the log base b of x plus the log base b of y. We have the quotient property that says if we have the log base b of x divided by y, we can break that up into the log base b of x minus the log base b of y. And we have our power property. Our power property says that we have the log base b of x to the p, where we bring that exponent out in front as a multiplier. So the exponent comes out in front times the log base b of x. So let's take a look at example 1. And what we're going to do is we are going to expand these logarithms using these properties up on the top. The directions say expand each expression. Each logarithm should involve only one variable and should not have any radicals or exponents. So the first thing we want to look at in letter A is we have the log base 3 of x to the 6th times y. Since we are multiplying two things in here, we can use a product property that says multiplying is the same as adding those two together. And we can rewrite this as the log base 3 of x to the 6th plus the log base 3 of y. Again, we're multiplying in here. We can add the logs of both of those together. My next step then is to get rid of my exponent. Since I have this 6 on my x, I can go ahead and use the power property that says that this 6 can come out to the front as a multiplier. And I get 6 times the log base 3 of x plus the log base 3 of y. We're going to look at letter B as well. So in letter B, we have the log of the cubed root of x to the 5th times z divided by y squared. What we're doing is we're taking this expression in the numerator and dividing it by the denominator. So your first step is to break up that fraction, that division, using the quotient property, which says we can take and subtract those two terms. So I'm going to take the log, and since I don't want any radicals, the cube root is the same thing as raising something to the 1/3. So I have the log of x to the 5th times z raised to the 1/3, and I'm subtracting the log of y squared. Then what I can do is this 1/3, this exponent, I can bring that out to the front using the power property. And at the same time, I can bring this exponent out into the front, again, using that power property. And that's going to look like this. 1/3 times the log of x to the 5th times z minus 2 times the log of y. Then if I take a look at this problem, now I have still multiplying two things inside this log here. And I can break that up, remembering, though, that this 1/3 is being multiplied by this whole thing. So my next step here is I have 1/3 times the log of x to the 5th plus the log of z. And then I can't forget that I still have all of this, which is minus 2 log of y. And then my last step is I still notice that I have an exponent here, so this 5 needs to come into the front of this log. And my final answer would look like this. 1/3 times 5 times the log of x plus the log of z minus 2 times the log of y. And that's expanded all the way out. I would like you to do the try this, which is below, and then let me know if you have any questions. So you can pause it now and unpause it when you're ready to check. If you did number 1 correctly, you should have gotten the log base 4 of x minus 6 log base 4 of y. And if we did number 2 correctly, you should have gotten the log of 6 plus 5 times the log of x plus 4 minus 3 times the log of x. If you have questions, again, please let me know.